Absolute value equations. Recall from earlier math courses that the definition of absolute value is the absolute value of a number, x, is written as an x between two bars, and it's the distance that the number x is from 0 on the number line. Here's an example. If you were to solve the equation, the absolute value of x is equal to 4, there would be two solutions, and those solutions would be positive 4 and negative 4. The way to check that this answer is indeed correct is if you take negative 4 and substitute it in for x. The absolute value of negative 4 is 4, so this one works. Similarly, the absolute value of positive 4, when substituted in for x, does indeed equal 4. Also notice that the distance from positive 4 to 0 and the distance from negative 4 to 0 on the number line is 4, and that's what the absolute value is measuring. It's measuring the distance. So the number line above is the graph of the solutions negative 4 and positive 4. Notice again that each solution is 4 units from the origin, and it follows that the absolute value of negative 4 is equal to the absolute value of 4, which is equal to 4. And by agreement, distances are always considered to be non-negative values. It can also be stated that the solutions to the absolute value equation, the absolute value of x is equal to d, are opposite values. This idea is captured in the statement, the absolute value of opposites are equal, meaning the distance from 0 on the number line to two opposite numbers will be the same distance. Two expressions are opposites if their sum is 0, and it follows that a and b are opposites if and only if a plus b equals 0. So if a was, say, 2 and b was negative 2, if you add those two together, you would indeed get 0. Similarly, the absolute value of a will equal the absolute value of b with these two values, and we can check that as the absolute value of 2 is that equal to the absolute value of negative 2? And yes, they are. 2 equals 2. So this is indeed a true statement. There are some basic absolute value rules to remember. If you have two unknown variables and they're being multiplied together inside of the absolute value, you can rewrite it as the absolute value of the first variable times the absolute value of the second variable. That way, the results will always be positive. We have this other property that a constant k times b inside of the absolute value is equal to, you can bring k out and keep b in the absolute value as long as k is greater than 0. So for example, if we had a k value of 2 and we had the absolute value of 2b, we can actually take the absolute value of 2 and bring it out. It's 2 times the absolute value of b. So this is an example of the property that is showing here. Again, the key emphasis is that our k value must be a positive number. And the third property is the absolute value of the quantity a minus b is equal to the absolute value of the quantity b minus a. Now let's try to answer these true or false questions. Our first statement is that negative 13 and 13 are opposites, implies that the absolute value of negative 13 is equal to the absolute value of 13. This is indeed a true statement. Because these two values are opposites, if you take the absolute value of each one, they will be equivalent to one another. Now let's look at number 2. X minus 5 and 5 minus x are opposites, implies that the absolute value of the quantity x minus 5 is equal to the absolute value of the quantity 5 minus x. This is again a true statement, and we'll just substitute a random number. We use 1 in for x. And if we evaluate both of these, 1 minus 5 is negative 4, and the absolute value of negative 4 is 4. And then if we subtract 5 minus 1, we get 4, and if we take its absolute value, it is also 4. So that is why this property is indeed a true statement. Okay, now let's look at the third one. The quantity x minus 9 and the quantity x plus 9 are opposites, implies that the absolute value of the quantity x minus 9 is equal to the absolute value of the quantity x plus 9. Well, this one's definitely false because these are not opposites. If we picked any random number for x, I'll use 1 again, and we substitute those in here, we're going to get the absolute value of 10, and we're going to get the absolute value of negative 8. And these two values are not equal to one another. Now let's look at number 4. We have the quantity negative x minus 3 and the quantity of x plus 3 are opposites, implies that the absolute value of the quantity x minus 3 is equal to the absolute value of the quantity x plus 3. Well, this is indeed a true statement. And the reason we can say that is we could actually factor out a negative 1 from our first set of terms here, whether it's inside the parentheses or inside the absolute value. If we do it from the parentheses and we factor out a negative 1, we'll then have x plus 3. So the negative of x plus 3 and x plus 3 are opposites. That's true. And then if you take the absolute value of opposites, they will be equal to one another, and that is true. And if we actually substitute this negative 1 times x plus 3 inside of our absolute value, we can then take the absolute value of negative 1 and take the absolute value of x plus 3. And then when we take the absolute value of negative 1, it will just be 1. So we will have the absolute value of x plus 3 is equal to the absolute value of x plus 3. And these indeed are, that is a true statement. So that is why number 4 is true. All right, now let's look at number 5. The absolute value of 5 times a is equal to 5 times the absolute value of a. This one is also true, because remember, when you take the absolute value of any positive number, it's going to be positive outside. So you can just pull that constant out, or that coefficient out, as long as it is positive. So that is a true statement. Now let's look at 6. The absolute value of the quantity x times y is equal to the absolute value of x times the absolute value of y. This is also a true statement. And the reason that this is true is because as long as we take the absolute value of both unknown variables, we will still get the same positive output value. So now let's look at 7. The absolute value of the quantity x times y is equal to just x times the absolute value of y. Well, this one's false. What if x was negative 1? Then you'd have the absolute value of negative 1 times y. That would just be absolute value of y as a result there. But then if x was negative 1, you would have this negative outside, making it a false statement. So that is why number 7 is false. Now let's look at number 8. So we have the absolute value of the quantity 12 minus 2x. Is this equal to 2 times the absolute value of x minus 6? Well, if we were to take our first one and simplify it, we could write it as 2 times the absolute value of 6 minus x. Actually, these should be in parentheses. They're still inside of the absolute value, but I just factored a 2 out. And the question is this equal to 2 times the absolute value of x minus 6? Well, we can now pull the 2 out because it's a positive coefficient. And we would have 2 times the absolute value of 6 minus x. And is this equal to 2 times the absolute value of x minus 6? This is a true statement because the absolute value of 6 minus x and the absolute value of x minus 6 are going to be opposites of one another. And the absolute value of opposites are indeed equal to one another. So this is a true statement for number 8. And now let's look at the final question, question 9. The absolute value of the quantity negative 9 minus 3x, is that equal to 3 times the absolute value of the quantity x plus 3? Let's actually try to factor some things out and see what happens. So we can definitely keep the absolute value here, and then we have a -3 a part of both of these two terms inside the absolute value. And when a -3 is factored out, we will be left with +3 plus x, still inside the absolute value. Is that going to be equal to 3 times the absolute value of x plus 3? Well, we can take the absolute value of -3 and then have 3 plus x inside of the absolute value. Is that equal to 3 times the quantity, or the absolute value of the quantity x plus 3? Well, the absolute value of -3 is +3. And then remember, addition is commutative, so you can switch the x and the 3 around and still get the same result. So 3 times the absolute value of x plus 3 is indeed equal to 3 times the absolute value of x plus 3. So this is indeed a true statement for number 9. And here we see the solutions to these 9 true-false examples, and they do indeed match the solutions that we found. True, true, false, true, 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 false, true, and true. Here's another example. Use algebra to prove that the statement is true. We have the absolute value of the quantity -12 minus 6x is equal to 6 times the absolute value of the quantity x plus 2. So let's first begin with the left side of this equation. So we still have inside the absolute value, we have a common factor of -6 here that we can substitute out. And when we divide -12 by -6, we're left with 2. And when we divide -6 by -6, we get a +1. So we have just plus x still inside of the absolute value. And we're trying to prove that it is equal to 6 times the absolute value of the quantity x plus 2. Now, because we have two separate terms inside of the absolute value, we can take the absolute value of each one. So the absolute value of -6 times the absolute value of 2 plus x. And then if we take the absolute value of -6, we get 6. And then, again, by the commutative property, we can switch around the 2 plus x to become x plus 2. And that is exactly what we needed to get to. And here's the solution, and it does indeed prove that the absolute value of the quantity -12 minus 6x is equal to 6 times the absolute value of the quantity x plus 2, as we had found when we worked through it. The absolute value equation of the form, the absolute value of the quantity x minus c is equal to d, where d is greater than or equal to 0, has two solutions. X is equal to c minus d, or x is equal to c plus d. Now, what does that exactly mean? It means that if the distance is greater than or equal to 0, meaning you have a positive number on one side of the equal sign, when you have an absolute value equation, you're going to have those two solutions. And it is set up as follows. You could have that x minus c is equal to positive d, or x minus c could be equal to negative d. And then if you add c to both sides in each equation, you would get that x is equal to c plus d, or x is equal to c minus d. So that's how we get these two solutions. X is equal to c minus d, or x is equal to c plus d. The solutions are a distance d units to the left and to the right of your center point C. Now let's try to solve some exercise problems. Exercise A, solve for x and graph the solutions on a number line. We have the absolute value of the quantity of 10 minus 2x is equal to 6. Let's first start by solving the equation. So notice 10 and -2 are both even numbers. So let's pull out a 2, and then we'll have parentheses inside of the absolute value. we'll have 5 minus x is equal to 6. We can factor the 2 out and just bring it out because the absolute value of a positive number is that positive number. So we have 2 times the absolute value of 5 minus x is equal to 6. If we divide both sides by 2, we'll get the absolute value of 5 minus x is equal to 3. And then because of the rule of opposites, you can also rewrite the 5 minus x inside of the absolute value as x minus 5, and that's still equal to 3. And then recall that the absolute value of x minus c is equal to d produces 2 solutions. We have that x is equal to c plus d, or x is equal to c minus d. So therefore, in this problem, we have that x is equal to 5 plus 3, or x is equal to 5 minus 3. So our x could be 8, or our x value could be 2. Then if we were to graph these on the number line, so here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10. We have positive 2 and positive 8. Notice that they are both 3 units away from our center point 5, which is right here. So we have 5 here, and our 2 solutions are 8 and 2. Now let's look at exercise B. A graph of solutions, the red dots, of an absolute value equation is shown. What absolute value equation is it? So our solutions are negative 3 and positive 7. And notice that the distance from negative 3, 1, 2, 3, 4, 5, and 7, 1, 2, 3, 4, 5, to the center point of 2. So the center point is 2 from negative 3 and 7, and the distance away from the center point is always 5. So we're going to have an equal to 5, because that represents the distance. And then inside the absolute value, we're going to have x minus our center point, which is 2. So this is the absolute value equation that is represented by this number line graph. And here we have the solutions to our first 2 exercises, and the solutions shown do indeed match the solutions that were found. Now let's discuss modeling with absolute value equations. The graph of the absolute value model equation, the absolute value of the quantity x minus c is equal to d, is given below. We have the center c, and the distance d units from the center c will give us our minimum, which is c minus d, and our maximum, which is c plus d. If the distance d is greater than 0, the graph of the absolute value model equation, the absolute value of the quantity x minus c is equal to d, produces 2 solutions, as shown above. Let's call the smaller solution the minimum, and the larger solution the maximum. With this, we can use the model equation to describe real-world situations where minimum and maximum values are important. Here's an exercise that we're going to work on solving. Proper tire pressure allows a mountain bike to ride smoothly and to avoid flats. The manufacturer's air pressure recommendation for mountain tires is 30 plus or minus 5 psi, which is pounds per square inch. Sketch a graph that shows the minimum and maximum recommended tire pressure, or capital P, values, and write an absolute value equation consistent with this scenario. How could we end up starting this problem? The first step is usually to identify key pieces of information. So let's actually do that. We have 30, a plus or minus, and then we also have 5 psi. Now the key plus or minus text that we have here tells me that that is going to be the distance value. At least 5 is going to be the distance value. And then 30 is going to be our center point. So let's actually start graphing what we have here. Our center point is going to be 30. And then we can go 5 units above plus 5 psi. And we can go 5 below. So this distance will also be 5. So if we go 5 less than 30, we will end up being at 25. And if we go 5 more than 30, we will end up at 35. So these two special points that we found, 25 psi or pounds per square inch and 35 pounds per square inch, are going to be our minimum and maximum values that we have. So now let's try to write a model absolute value equation. So we have the absolute value of our pressure P minus our center point of 30 has to be equal to the distance, or the absolute value, which will end up being 5. And here is another version of the graph. It again shows our center point of 30 with the minimum of 25 and a maximum of 35. And the absolute value equation that models this is the absolute value of the quantity P minus 30 is equal to 5.